So the next chapter that we deal with in physics is electrostatics, capacitance and dielectrics. The first question is a pretty simple one, which requires a little bit of concept. There are two identical conducting spheres. Mind the words, two identical conducting spheres of negligible radius having opposite sign charges, which attract each other with a force of 0.108 newtons when kept at 0.5 meters separation. Now what happens is that these spheres are connected by a conducting wire, and then the wire is removed. It is then seen that they repel each other with a force of 0.036 newtons. We need to find out the initial charges on the two spheres. So let us draw the diagram. Initially they are 0.5 meters apart. Let this have a charge plus q1 and let this have a charge minus q2. q2 is the magnitude and q1 is the magnitude. Now they attract each other with a force of 0.108 newtons. Therefore we get the equation as k q1 q2 upon half whole square, that is 0.5 whole square, is equal to 0.108. This is the first equation that we get. Now what happens when we connect these two by a conducting wire? We know that a conducting wire has a lot of free electrons, so there will be a transfer of electrons. So since these two spheres are identical and conducting, therefore the final charge on both the spheres will be same, because there is no biasness. Therefore by symmetry, since these two spheres are identical, conducting spheres and connected by a conducting wire, therefore charge transfer can take place, and therefore the final charge on both the spheres will be same. Let the final charge be q. Now we know that by the principle of charge conservation, 2q will be equal to q1 minus q2. Since the charge cannot be created nor be destroyed, therefore the total charge finally will be equal to the total charge initially. Therefore we get q is equal to q1 minus q2 upon 2. Now it is given that they start repelling each other with a force of 0.036 newtons. So let us write the repelling force, k q square upon 0.5 whole square is equal to 0.036. Q is equal to q1 minus q2 upon 2, therefore we can write over here q1 minus q2 upon 2 whole square upon half whole square is equal to 0.036. This 2 can be cancelled with the 2 here. Therefore 9 into 10 raised to power 9, we know that you must remember the value of k. The value of k is 9 into 10 raised to power 9 in SI units. q1 minus q2 whole square is equal to 36 into 10 raised to power minus 3. This is 4, 10 raised to power minus 12. On solving this we get q1 minus q2 whole square is equal to 4 into 10 raised to power minus 12. Therefore we get q1 minus q2. Let us take q1 greater than q2. q1 minus q2 is equal to 2 into 10 raised to power minus 6. Therefore this is one equation and this is the second equation. We can on solving these two equations, we can easily get the value of q1 and q2. The value of q1 comes out to be equal to 3 into 10 raised to power minus 6 coulombs, and the value of q2 comes out to be equal to 1 into 10 raised to power minus 6 coulombs. So final answer becomes equal to, the charge on the two spheres can be 3 microcoulomb and minus 1 microcoulomb, since this was negative initially, or it could have been the other way around. It could have been minus 3 microcoulomb and plus 1 microcoulomb. So if there are multiple options, you have to take both the answers. So final answer for the initial charges on the two spheres comes out to be either plus 3 minus 1 microcoulomb or minus 3 plus 1 microcoulomb.